Calculus Kids. This is Dr. Callahan with week 5 Thursday. How are you guys doing? Go ahead and pause the video and answer the following questions. Okay, let's go ahead and create the assignment for today on MS Team. You guys are in Calculus for second period, and let's just go up here under assignments and make sure you guys are checking in with me, especially for your attendance. So I'm going to go ahead and assignment, upload. Your instruction is basically to view the assignment. Make sure you guys watch the video in its entirety and then also upload your assignment if there's anything that requires to be uploaded. But if it's just something like today where you're going to be practicing with examples in your guided notes, you don't have to do that. Make sure you check in with me by 9:41 a.m. for Thursday for second period. That's generally when I take the attendance. And today our topic of discussion is going to be on a continuation of finding integrals of natural logs, and it is more difficult or complex questions of natural logs. Okay, so I'm just gonna go ahead and include that here. So complex integral of natural logs. Let's go ahead and copy that over. Okay, so week 5 Thursday, Calc AB, semester 2. All right, and so it is going to be worth 10 points, and make sure you have this done by the end of second period is what I'm suggesting. All right, so with that said, let's go ahead and continue with our lesson today because we have a lot to go over. Okay, so today's breakdown is as follows. You're going to be reading my notes over natural logs. My goodness, what just happened? Okay, and we're going to go over some whiteboard practice called Dead or Alive with long division and integrals. I don't know if you guys remember, but do you remember synthetic division and then long division with polynomials back in Algebra 2 honors? We're going to go ahead and utilize that skill set and integrate it into integrals of natural logs for today's lesson. All right, so with that said, go ahead and take a look at our breakdown for today. So go to page 5 or week 5 Thursday, pause the video and then read my notes on natural logs and integration of natural logs. Here are some of the guidelines. Here are some of the examples. There are 11 in all, and then also a quick reviews of properties of logarithms, how you expand them, and how you bring the power down in front of the ln. Okay, and then this is going to be from your example in class. So make sure you guys have this page. On the left are the integrals of the 6 basic trigonometric functions. These 6 you absolutely must memorize. And then similarly, I have the differentiation for the trig functions on the right side as well. So you have the derivative and the integral, so you can compare them side by side. Okay, so we're going to go over a quick question. It's actually just one question, but this one question is going to take us quite a long time to actually cover. So go ahead and turn over to page week 5 Thursday, and it is example 4. Okay, so this question is comparing and asking you to find the local extrema, which is the content that we talked about unit 3. Of maximum and concavity, but now we're going to go ahead and throw in natural logs as well. So I have a checklist right over here that you guys can go ahead and take a look and read, and this is what we're going to be doing to find those information. All right, so let's take a look at this. So to find the critical point for max and min, you will first need to go ahead and find the derivative of this. So as I'm looking at this right here, I'm probably going to use the quotient rule. So f equals x, f prime equals 1. G equals ln x, g prime equals 1 over x. G squared equals, well, actually, I'm sorry, hold on a second. No, I won't have to use the quotient rule. G squared would be ln x squared. There we go. All right, so then f prime of x is going to be equal to f prime times g, so that's just a ln x minus f times g prime, and x times 1 over x is just going to be a 1, all the way over ln x squared, which is g squared. In order to find your critical point, remember your derivative, which is your slope, have to be set equal to 0, because remember, that's when the max and min is going to be located in, when the slope of the tangent line is equal to 0. So just remember, this is a 0 over 1. My goal here is to solve for x. So if I were to do that, let's go ahead and see what happens then. I'm going to go ahead and cross multiply, and I end up with ln x minus 1 equals 0. So at this point, I'm going to add the 1 on both sides. X ln x equals a positive 1. Now, if you go back to Algebra 2 honors, the way that you can solve for ln x, how you can get rid of this, how do you get rid of ln is you insert an e on both sides. So ln cancels, x is now by itself. E to the 1 power, you can put into your calculator, or you can go ahead and just write it down that I have here. It's going to be 2.72. So this is your critical point. So I know that I have to put this on a sign line, because if I test the left and right side, it's going to give me a max, or excuse me, it's going to be a positive or a negative slope. And remember, it's going to tell me if it's a max or min. So let's go ahead and pick a point of this. I'm going to go ahead and do f prime. On the left side, I could do a 0. On the right side, I'm going to do a 3. Okay, and so then what you're going to see is that this is going to give you a negative slope followed by a positive slope. So it's going to be something like this. So obviously at this point, you know that it's going to be a minimum. And of course, I want the location of this. So it's going to be a 2,72 or 2.72. And to find the y value, you have to do a f of 2.72. And if you have a calculator, you will go ahead and plug this into that. So your answer is going to be 2.72, comma, 2.72. And this is where your minimum is going to be located. And that's the first part of this. Because it also asks you to find the inflection point, which is the second derivative. So yeah, you guessed it, we would have to keep on moving with this. Now, in case you did not get a 2.72, remember back in Algebra 2 Honors, there is a mode in your calculator that you have to change that mode into a radian. So make sure you have that changed correctly, so that way you get the right answer. Oops, let me rewrite that. There we go. All right, so then let's go on to the next part of this. Okay, so I'm just gonna go ahead and copy my f prime of x, because I guess what I'm gonna be using this in my next part as well. Oh my goodness. Okay, hold on a second. This thing is freaking out just slightly. There we go. All right, so let's go on to the next part of this, which is finding the second derivative. Okay, now, so the second derivative, it is going to be f double prime of x, and unfortunately, I feel like we're gonna have to do this one more time with the product or quotient rule. So I'm just gonna do this on the side. F is gonna be the numerator, ln x minus 1. F prime, derivative of ln x is just 1 over x. Derivative of negative 1 is just 0. Your g is gonna be the denominator of ln x squared, okay? And so then your g prime is going to be, and this is going to do the chain rule, I'm going to bring down the 2. So 2 ln x times the chain of ln x, the derivative of ln x, 1 over x. So if I were to write this a little bit better, it will look like 2 over x ln x. Okay, so then I need to have my g squared, and my g squared is just going to be ln x squared, so that's ln x to the 4th power. Okay, so now that I have this information, let's go ahead and move forward with the quotient rule. So f prime times g is just going to be ln x squared over x, or 1 over x ln x squared. Okay, that's f prime times g. Minus, now you're going to do is you're going to do f times g prime. So I will have a ln x minus 1 times 2 over x ln x. So right now, as I'm looking at this, I notice that both of these have a 1 over x. This is a 1 times 2, by the way, okay? So what I want to do is I want to take that 2, and because I'm thinking maybe I can factor the 1 over x out and see if I can maybe just distribute that 2 in here. So if I do that, then what I can take out from this is I will have a 1 over x ln x, because there's 2 of them here, 1 over x ln x. So f double prime of x is equal to, and don't worry, I haven't forgotten about g squared, it's still there, 1 over x ln x. And if I factor that out, then what I have left is ln x from the first part right there, minus, I took the 1 over x ln x out, so I have a 2 left, so I distribute the 2. If I distribute the 2, I will have a 2 ln x minus 2. But because I have this negative right here, negative times a positive is a negative 2 ln x. Negative times a negative 1 is a positive 2. So just be careful with that. And this is going to be all the way over g squared, which is ln x to the 4th power. But then as you guys can see right here, you can go ahead and cancel the ln x and this ln x, which will give me an ln x to the 3rd power. And then if I want to get rid of this x here, I can multiply x on top and an x on the bottom, which will cancel that part out. So then I would just have ln x, and I'm going to give you the checklist so I don't go ahead and screw this up, equals ln x minus 2 ln x plus 2 all the way over x ln x to the 3rd power equals to 0. Over 1. Okay, now let's go ahead and cross multiply this. So then I have ln x minus 2 ln x plus 2 equals 0. And if you look at it, there's a 1 right here. So what's a 1 ln x minus a 2 ln x? Isn't that a negative 1 ln x? Move that 2 over, you get a negative 2. And then what you can do here is you can go ahead and get rid of the negative 1. So ln x equals a positive 2. Now it looks a lot simplified. So I'm going to put an e on both. That cancels. X is equal to e squared, which is actually going to equal to e to the 2nd power, if you type into your calculator, is 7.38, and that's your point of inflection. That's your point of inflection right there. Okay, so once I found my point of inflection, take a look at your steps here. Okay, you got that, got that, solved, got a point of inflection. What's your last step? Test for concavity using a sign line. So from the previous example, I am going to okay, there we go. I'm going to do a sign line. So here's my sign line, and this is f double prime of x. My point of inflection is x is equal to 7.38. And I'm going to go ahead and test my points for concavity. F double prime of x, left side of this could be at 0. Right side of this could be at 8. Remember with your f double prime of x, your f double prime of x is your f double prime of x is going to be -1. Let's go and write this down. Is going to be -1 ln x plus 2 over x ln x cubed. Okay, so that's we're going to plug in the 0 and the 8 into this formula. And then from there, you're going to find out that oh goodness gracious, come on. You're going to find out that this part here is going to give you a positive and the 8 is going to give you a negative. And because it's going to be a positive followed by a negative, what that means is that you have a concave up and the location of left side of that point, so -infinity up to 7.38. And there is a concave down from that point, 7.38 to positive infinity. And that concludes your answer for that. All right, let's continue on to practice with a few other problems. So normally in class, I have you guys play this game, but since you're at home, you can just go ahead and play and tag along with it. All right, so we're gonna go ahead and start out with something easy. Go ahead and find the integral of this. So pause the video and try this on your own, a piece of paper. All right, so the first thing I always like to do is I like to write down the formula so that way I know exactly what I'm trying to achieve. I know that the integral of ln 1 over u is gonna be ln u plus c. So I know that this right here is my goal, is I wanna somehow manipulate this equation to get to an integral of 1 over u, okay, du. So with this said, I'm going to have to use a u substitution. So let's just say let u be the denominator, x squared plus 6. Du is going to be the derivative of x squared plus 6, which is 2x dx. Dx is going to be a du over 2x. And immediately I can see that I'm going to be able to cancel this and this, which is perfect. So what I'm going to do next is integral x over u, replace your dx with a du over 2x. And I'm going to go ahead and cancel this part here, which is a 1/2 integral 1 over u du. And look how pretty that is. It's like very simple. So then when I integrate this 1/2 ln u, replacing u back, x squared plus 6 plus c, and there is your answer. Now, another way of writing this, you could write it down as ln x squared plus 6 to the 1/2 plus c. This is another option on the multiple choice exam. All right, I'm gonna have you guys do this one on your own. So pause the video and give it a try. See you're able to do it. Okay, so with this one, you're gonna say let u equals x plus 1, which means that your du, the derivative, is just dx. Oh, So as I'm looking at this right here, even if I replace a dx, it's just going to be a du. I can't cancel out the 2x. So then remember what I asked you guys to do is solve for x in terms of u. So if I know that u equals x plus 1, I also know that x is equal to u minus 1. So I'll be using that later on. But for now, let's go ahead and move forward. 2x over u times du. So now that I know that this x is going to be equal to u minus 1, I can go ahead and distribute this to the integral of 2u minus 2. And because it's on a fraction, I could separate them. I could do a 2u over u minus the integral of 2 over u du. Okay, so let's go ahead and do that. Oh, you know, I forgot a square. I'm sorry. There's a square. Ta-da, right there. That matters. So I have a square and a square. Sorry about that. Okay, so then this part cancels, and I have the integral of 2 over u, or I have the integral of just 2 over the integral of 1 over u, which is perfect because that looks even better. I know that the integral of this first part right here is just going to give me a 2 ln u. And then, of course, the second one here, this piece right here, I am going to move that u up. So I have a 2u to the negative 2. Add a 1 to both sides, or to the side, gives me a negative 1 divided by negative 1. So the integral of this is just going to be a negative times a negative, which is going to be a positive. 2 u to the negative 1 power, bring it down, u. And that's it. So then my next, or plus c, sorry, forgot plus c. Let's go ahead and replace the u with an x plus 1. And that is it. This is your answer. Okay, let's go on to the next part, which is example 3. I'm going to go ahead and pause the video and you guys give this one a try. Okay, here are your steps if you would like to take a look at it. Okay, let's go on to the long division part. I'm going to go back to this in a second. But first I'm going to do is I'm going to talk about this one over here. I want to make sure I set this up correctly. And so far, it's not looking like it is, but that's okay. I'm going to go back and modify this a little bit. Okay, here we go. All right, so when you have questions that look like this, where the numerator is greater than the denominator with the powers, you're going to realize that you could go ahead and try u substitution, but you're not going to get anywhere. So let's say, for example, u equals x squared plus 2. Du is 2x dx. How are you going to get rid of x to the fourth plus x minus 4 with a 2x? It's just not going to happen. Now, let's say you decide to let u be x to the fourth plus x minus 4. Well, du is going to be 3x squared plus 1 dx. How are you going to get rid of this x squared plus 2 with 3x squared plus 1? I mean, like, there's just no way for you to get rid of that. So these are all just good suggestions, but ultimately they're just kind of a waste of the time. So we're not doing that. I would have to go back and rewrite this somehow algebraically before I attempt to use u sub to integrate this. So remember, back in algebra 2 honors, you're able to divide polynomials because the numerator for this one is a power of 4 and the bottom one, the denominator, is a lot smaller. So another way of writing this is x to the fourth plus 0x to the third plus 0x squared plus x minus 4. Bottom, x squared plus 0x plus 2, okay? And what we're going to do with that is we're going to put it into a division. So x to the fourth plus 0x to the third plus 0x squared plus x minus 4 divided by x squared plus 0x plus 2. Okay, so then looking at this here, you're going to ask yourself, x squared times x squared is going to give me x to the fourth, but keep in mind you have to distribute into everything into the parenthesis. So plus 0x to the third plus 2x squared. And then remember, when you subtract this, it becomes a negative, negative, and a negative. Okay? That cancels. That just gives you 0x to the third. That gives you a negative 2x squared, and you bring down the x. Let's repeat this process all over again. You're going to do plus 0x, and again, you're going to multiply that through. So 0x to the third plus 0x squared plus 0x. And again, you're going to subtract it, which means you're going to have a negative, negative, negative. So this doesn't get canceled. This part gives you 2x squared. X minus 0x is just going to be x, and then you bring down your negative 4. Okay, so last one. I'm going to have to put a 2x, or not 2x, just a 2. So distribute that 2 in here. 2x squared plus 0 times 2 is 0x plus 4. And ta-da, when you go ahead and subtract it, you're going to have a negative, 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 which cancels everything into a 0. So what this means is that you will have to write this as the integral. Okay, your answer is just going to be the answer up here, which is a quotient. So x squared, you don't need to care about the 0. Oh, you know what? I forgot to put a negative right there. So this has to be a negative 2. Sorry. Negative 2, but it's okay because that's going to be a negative. So then that will be a positive. Whoops. Okay. So it turns a positive. This doesn't even matter because it all cancels. But anyways, it has to be a minus up there. So x squared minus 2 dx. Well, that looks a whole heck of a lot better because now I can go ahead and integrate this separately. Okay, so if I integrate the first part, add the 1 equals a 3 divided by the 3. So I have x to the third over 3 minus, what's the integral of 2? It is going to give me a 2x. And remember, in order to write this, you will have, oh, you know what? I just realized here. The x minus a 0x doesn't give me a 0, it actually gives me an x. So plus, remember, it's always, when you do this, it's going to be plus the remainder over the divisor. So plus x over x squared plus 2, which is your divisor. So you have to integrate this part as well. Oops, sorry about that. And so that's okay because this is not going to be that difficult. You just have to go ahead and use a simple little u sub, and I promise you it's not going to be too painful. So we're just going to say let u be x squared plus 2. Then you're going to do the du, which is going to be 2x dx, okay? And that's good because this part will cancel. So when I do the integral of this, it's going to be a x over u times dx. Replace that dx with a du, so that's a 2x. So then what's going to end up happening is I'm going to cancel this with this, And I just have an integral of 2 over u, or 2 integral of 1 over u, which is going to give me a 2 ln u, replace the ln with the x squared plus 2 plus c. So you're like, okay, what is your answer, Callahan? It's this piece right here plus this piece right here. And that's your answer, you guys. All right, last question. I'm going to have you guys just go ahead and practice on your own. It's this one. Pause the video. All right, and here is your answer for this one here. All right, you guys, that was a long lesson. I'm sorry. As always, stay safe and healthy. I'll see you guys next time. Take care.